Hey guys, this is a contactor. It's one of the most commonly serviced and most important items in your AC unit. And in today's video, I'm going to talk to you guys about everything you need to know about this device in your AC unit, how important it is, how it works, how to troubleshoot it and know if you're having problems, and even how to replace it if you have to replace one. Stay with me and let's get at it. Hey guys, welcome back to the channel. To all my longtime subscribers, welcome back. And if you guys are new here and you enjoy the content, don't forget, hit that subscribe button so you guys can stay up to date with all things that I do DIY around the home, including reviews. Guys, today I got an awesome video for you. This here is a contactor, and if you guys own an HVAC unit, AC unit, a heat pump, you're gonna have one of these things on your outdoor unit. And this is a super important thing. It's one of the most serviced parts on your AC unit. And in today's video, I'm gonna teach you guys how to do everything related to this thing right here. It's called a contactor, and I'm gonna let you guys know what it is, how it works. We're gonna do a demo of it. And after this is done, you'll be able to troubleshoot this all on your own and replace one if you need to. So this video is going to be broken down like this. It's going to detail a contactor and talk about how it works, how to troubleshoot it, and how to replace it. So if that's what you're up to, this is the video for you. Now, I'm going to be doing a live demo that I'm going to set up on my workbench to show this thing in action and simulate it if it was inside of your unit. And that's how I'm going to be able to talk you guys on how to troubleshoot it and test this thing and make sure that it's working properly. All right, so here's my setup here for you guys to help you visualize what a contactor is and how it works. The first thing I want you to understand and realize is that a contactor is nothing more than a switch. If you think about it as a light switch, then this is going to make it a lot easier for you. All it really does is that it has power that comes into the contactor and it's activated by your thermostat when it calls for cooling. It has an electromagnetic coil that's located inside here that gets 24 volts. It closes the contactor and the voltage passes through the contactor to your compressor and your fan to start the cooling or heating process. Most contactors have a manual button, but this one is covered, as you can see here. There's a button inside here, just like this, that you can use to switch this thing on and off if you need to test it. All contactors are made up of the same parts. You have the bottom side of your contactor, which is where your incoming voltage comes in. You have the opposite side is where your voltage goes out to your compressor or your fan motor or your capacitor. And you have the low voltage side of your contactor, which is powered by 24 volts, which is coming from the inside of your house, from your thermostat. And last but not least, you have a button on the front, which is a manual button, as you can see here. This is controlled by the electromagnetic voltage that's passing through here. When your system is set for cooling, it sends 24 volts through the electromagnetic coil. The coil becomes energized and it pulls the switch closed and passes voltage from this side to this side. Once your system reaches temperature and your thermostat is satisfied, it's going to de-energize and it's going to remove the 24 volts from the coil, and your switch is going to de-energize, stopping voltage going from the incoming side to the outgoing side. So, for my setup here, what we have here is we have 120 volts coming in, which I'm going to plug in on this side of the contactor here. The coil, which is located on the middle, is connected to a 24 volt source, which I'm going to plug in. This is going to simulate my thermostat. And this in the middle here is the manual button on your contactor. Some of you guys will have a button that's just located here that you can press. But in my case, we have a little cap that's covering the button, but you can remove it and this will activate the button manually. On the top of the contactor here, we have the power that's going out, and I have it connected to a meter here so you guys can visually see, as well as I have my meter here, which I'm going to measure voltages to show you guys what actually happens during the whole process. Now let's talk about how this thing works in a normal circumstance. So we have our contactor plugged in. Now we should have power coming in at the bottom here. This should be 120 volts. As you can see on my meter, we have 120 volts coming in. Now, whenever our thermostat calls for cooling, 24 volts is going to be sent to this coil. I'm going to plug in my 24 volt adapter, and you're going to hear the contactor close, just like that. And now when you hear it close, you can see 124 volts is now passing through on these terminals up here and going to the meter. I can measure here. As you can see on my meter, we have 120 volts on the top side. And if I measure across the coil on this side, we should get 24 volts. And we have 24 volts. So there it is. That's how it works. Power comes in. Our thermostat sends 24 volts to the coil. The contactor engages and passes the 120 volts or the high voltage, whatever voltage you have, through to your compressor and to your fan. All right, now that we got the general gist of how this works, let's go ahead and talk about troubleshooting. So whenever you have issues with your condenser outside, you want to go ahead and check these things first. The first thing you want to do is you want to go ahead and check your incoming voltage. Here, you're going to place it at the bottom of your contactor where the lines come in from outside. If you have high voltage coming in, then you know that the first step is clear. If there's no voltage, then what you need to do is you need to either go to your breaker or you need to go to your disconnect and make sure that the fuse is not blown or the breaker has not been tripped. Once you've figured out if that's the cause, turn it on and check again for voltage. The next thing you want to do is you want to go ahead and manually press in the button on your contactor and make sure that it sends voltage across the coils. If you press on it here, you can see on my meter, it sends 120 volts. If I release it, it's going to go back to 0. My meter here holds it for a little while, but eventually it's showing flashing here, which means it actually has lost connection. As you can see, the voltage is 0. All right. So now if you press the manual button and you know that it sends voltage through, then that part is working. The next step you want to do is you want to go ahead and set your thermostat to cool or heat or whatever it is. And you want to measure the voltage to see what's going across your coil. So once your thermostat is set to cool, you can go ahead and measure to get 24 volts. If your contactor is energized without the thermostat being on, that means your contactor is stuck or it's bad. If you guys measure 24 volts and the contactor is not energized, meaning the button isn't depressed and you're not getting voltage through, it means that the contactor is bad. And the last step you want to check is if the contactor is energized and you measure the outgoing voltage, if there is no voltage, then the contactor is bad. If you have voltage and the unit is not running, then the problem is either with your capacitor, your fan motor, or your compressor. And I have videos for those as well. So if you want to, you can check them out to see how to troubleshoot those if you've gotten past this stage. Once you guys have run through all the steps and all the troubleshooting procedures, you are done. Now, if you figured out that your contactor is bad and you need to replace it, then the steps are really simple and I'll show you guys exactly how to do it. I'm going to break it down for you in 7 simple steps. If you need to replace your contactor, here's what you need to do. Step 1, you want to cut the power off, whether that means turning off your breaker or your disconnect. Once your breaker is off, you want to test again on the base of your contactor where the power is coming in to make sure that you have 0 volts and that the contactor is dead. There's no power going to it. The next step is pretty simple, pretty straightforward. You want to disconnect all the wires. I do recommend taking a picture of the setup so that you can put them back in the exact location. Or if you want to, you can disconnect the wires one by one and then connect them to your new contactor as you replace them. This is the integral part of connecting the contactor. Don't rush it, take your time. Now, the next step is you want to remove the screw that's holding the old contactor in. Typically, it's a single screw. You might have 2 screws, but you may have 1 screw depending on the scenario. Just loosen that screw and the old contactor should come out. Next step is you want to secure the new contactor and screw it all in. If you didn't connect your wires like you did in the first step, now is the time to go ahead and replace all the wires and connect them all up. Step 6, you want to go ahead, turn on your breaker or your disconnect or whatever it is, and you can measure the incoming voltage. If you have incoming voltage, then you know that the contactor is ready to go once it's called for cooling. The last step is turn on your thermostat to cool or heating or whatever it is, and you should be good to go. You can listen to it and wait for it to be energized and watch to make sure that your contactor is energized and it sends power to your compressor or your fan motor. All right? And just like that, you guys are now professionals on understanding what a contactor is. Guys, I hope you guys found this helpful, and after watching this, you guys should now be able to troubleshoot this, replace it, and understand exactly how your AC unit is being affected, if this thing is faulty or not. I'm also going to be doing another video and another series about other components to your AC unit, including your capacitor. I've already done one about replacing the condenser fan motor on my outdoor unit. So if you guys have a condenser fan motor that's going bad and you want to learn how to replace it, check out that video. It's somewhere around here. Apart from that, that's pretty much it. Thank you guys again for watching, and until next time, I'll catch you guys in the next video.